A major fishing company does its fishing in a local lake. In its first year of the company's operations, 2005, it managed to catch 100,000 fish. Due to population decreases, the number of fish the company was able to catch decreased by 9% each year. Write an equation that could be used to find how many fish, y, the company can expect to catch from the lake X, X years after 2005. So when I see a percentage here, we're going to keep multiplying by a percentage. That's a geometric sequence. And the geometric sequence formula is A1 equals, or AN equals A1 times R to the N minus 1. We might have to make a few modifications to this formula, but that's the formula we're going to use. This number here, AN, is the outcome, which in this case is how many fish. So we're going to change that to a Y. A1 is how many fish, the initial value, how many fish we started with. So that's going to be 100,000. R is the rate, which is what do we keep multiplying by to make the next value happen. So I'd like to put a 9% in there, but first of all, we have to use it as a decimal, not a percent. Second of all, if we multiply by 9%, we're going to end up with like no fish right away. And that's not really what's happening here. We're only losing a little bit of fish. That's because when you're decreasing in value, when you're depreciating, you don't use the percentage that you're losing. You use the percentage that you're not losing. So we need to do 100% minus 9% to get 91%. So the rate here as a decimal is 0.91. Now they said the number of years is X. So instead of N, we're going to use an X. Now we need to stop and think about this formula, because this formula initially has a minus 1 in it, but we need to see if that minus 1 is needs to stay. So what I'm going to do is I'm going to go to my Y equals, and I'm going to type 100,000 times 0.91 to the X. X represents how many years after 2005. So when this study started, the year was 2005, and we caught 100,000 fish. So if it is 2005, our X value should be 0, right? Because X measures how many years after 2005. So if I use this formula as is, and I go to my table, 0 should say 100,000. There should be in year 0, which we all know is year 2005, there should be 100,000. And when I go to this, it does show 100,000. We don't put the minus 1 there if the year we're starting with is year 0. If you have a year 0 in the problem, you don't want to have that minus 1. Let me show you if I put that minus 1 in the equation. You'll notice my table is off. It's saying 1 year after the study we'd have 100,000. That's not true. We don't want that minus 1 there because all that would do is move the table, all the table of values up or down. We don't want them moved up or down. We want the 100,000 to be lined up with year 0. So we don't want that minus 1 there. And then the second part of this question says, how many total fish did the company catch over the first 10 years to the nearest whole number? We could use the formula we just wrote, and we could plug in year 1 and find the answer, and year 2 and find the answer, and year 3 and find the answer, and do that for 10 years. But there's a formula to do this for us. This is called a geometric series. A finite geometric series. And the formula is Sn equals A1 parenthesis 1 minus R to the N over 1 minus R. So A1 is the starting value. How many fish did we start with in the first year, which is 100,000. One more 0. R is the rate, which we already decided is 0.91. Down below, we have the 0.91. And then N, same question as the last time. Do we want it to be 10, right? Because we want this to happen for 10 years. So now I'm just going to type this on my calculator. Make a fraction, 100,000, parenthesis, 1 minus 0.91 to the 10th, all over 1 minus 0.91. I'm going to hit enter. Now, you can see that this formula gave me a negative number because we did not, what did I type in wrong? Oh, I see it. We didn't put the decimal in front of the point. There we go. Same values, it's just now all the decimals moved over. All right. So after 10 years, they would have caught 6, 7 feet, 4, 2, 7 fish. It says round to the nearest fish, right? And just because I'm curious, I'm going to go back to my table and I'm going to check to make sure this is right. If I add up all these numbers on the screen, I should get 6, 7, 8, 4, 2, 7, right? Because it said the first 10 years. So let's just double check this. If I add up 100,000 plus 91,000 plus 82,810 plus 75,357 plus 68,575 plus 62,403 plus 56,787 plus 51,676 plus 47,025 plus 42,793. I'm actually going to stop at year 9. Because if the first year is year 0, then the 10th year is actually year 9, right? All these numbers are 1 off. 0 is actually the first year. 1 is actually the second year. 2 is actually the third year. So year 9, or X is 9, would be the 10th year. So I'm going to stop my adding there and hit enter. And I accidentally put a plus sign at the end. I'm going to hit enter. 678,426. Now I bet we're off by 1 because of rounding. I bet if I look carefully, all these blue numbers are going to be decimals. And we just lost. Yeah, there we go. See, look, there's a decimal there. There's a decimal there. We lost a little value just because I didn't use the decimals. I just rounded each of those values. So we did it right. The answer is 678,427 fish.